Hello everyone. We all know that in IC engines, conventionally hydrocarbon fuels are used completely. Okay. The major disadvantage which is associated with these hydrocarbon fuels is that they are a chief source of pollution in the atmosphere. Another major inherent disadvantage with these hydrocarbon fuels that are conventionally used, that are petroleum products, is that their availability and their renewability. To cater to this and to offset this particular disadvantage of their availability and renewability, there has been a constant effort and concentration on the research in order to find some alternative for the conventionally used hydrocarbon fuels in the IC engines. This has led to the research and development of certain alternative fuels that are currently being used in place of these common hydrocarbon fuels in the IC engines. In this lecture, we are going to study something about the alternative fuels. First of all, the first type are the gases. In gases, we have natural gas, which is further classified as liquefied natural gas and compressed natural gas. Then after that, we have liquefied petroleum gas. Other than this, we have synthetic fuels which comprise methanol, DME, that is dimethyl ether, and synthetic diesel. Another form of alternative fuel is the renewable automobile fuels, under which we find bioethanol and biodiesel. Then another alternative fuel category that we have is the sustainable automobile fuels, which might be powered by electricity from sustainable energy sources, hydropower, windmill, solar, etc., and such. Then hybrid electric vehicle and plug-in electric vehicle. Also nowadays, hydrogen is being used as a fuel by applying the means of a fuel cell. Let us go on a bit further and see what else is there to be studied in this particular topic. If we consider the alternative fuels over here, then the fuels, they are chiefly derived from two broad sources. They are fossil energy source and renewable energy source. From fossil energy source, we have three main categories, that is crude, natural gas, and coal. Crude, after refining, it gives you LPG, and after blending, it will give you more gas and diesel. Natural gas, it will give you LNG, PNG, and CNG. If it is subjected to synthesis, then it can give you synthetic fuels and methyl alcohol. Further, coal, when subjected to gasification and synthesis, it will give you again synthetic fuels and methyl alcohol. Further, wood, when subjected to gasification and through synthesis, again it will give you synthetic fuels and methyl alcohol. And if subjected to fermentation, it will give you ethyl alcohol. The same is the case with grain. When subjected to fermentation, it will give you ethyl alcohol. Vegetable oil, when esterification is done on it, it gives you biodiesel. Now, alternative automobile fuels are, over here we see gases, that is LNG, PNG, CNG, synthetic fuels, and methyl alcohol. Renewable automobile fuels are ethyl alcohol and biodiesel. For alternative automobile fuels like natural gas, it is derived from natural gas field via PNG and LPG. This LNG, it is cooled to below minus 127 degrees Celsius and converted into liquid, thereby reducing its volume by around, say, 600 times. This here is shown the supply chain of LNG from the gas reserves to the exporter, shipped through the containers and directly then to the importer. Then we have natural gas. In that natural gas, we have CNG, that is compressed natural gas, which is compressed to 3000 psi, or say 20,000 kilopascal, such that it gets reduced by 1% of original volume. Further on, in 1 liter of gasoline, equivalent energy is obtained from CNG to the tune of zero point 0.9 meter cube. Octane number in case of CNG is in the range of 130. On the other hand, as a drawback, it reduces 10 to 20% of the total power output that is obtained from conventional gasoline in an IC engine. In order to reduce the quantity of pollutants, CNG is preferably used in many countries in the public sector transportation. Then we have LPG, liquefied petroleum gas, which is obtained from the refinery. There are three categories over here that we see, that is C3, C4, and C3 plus C4. C3 is propane, C4 is butane, C3 plus C4 is obviously a mixture of the two. As far as the country-wise distribution of number of vehicles and dispensing sites are concerned, this table is an indication of how many number of vehicles are being used that are currently run on LPG and what are the facilities that are available for refueling these vehicles with LPG. This is a broad layout in which an LPG cylinder is retrofitted in a conventionally driven gasoline driven car. This is basically a bi-fuel car. You will see that underfloor gas tank mounting is being done over here for LPG alongside the petrol tank. Both these fuels are supplied through fuel lines to the conventional engine. Then in the dashboard you have a switch wherein you can switch the supply of fuel depending upon the condition of the IC engine when it is running. You need to mount gas injectors on the engine, and you also need to have a pressure regulator. The major disadvantage that we may find over here with LPG is that at the time of starting and cold running conditions, directly LPG cannot be used. First of all, you have to start running your engine on gasoline, and then when required running temperatures are attained, then you can switch to LPG. Then we have over here synthetic fuels. Synthetic diesel is found to be free of sulfur, and it also exhibits to have a higher cetane number. However, low temperature fluidity is considered to be a drawback. It is basically obtained from coal and biomass and also natural gas. When coal and biomass it is subjected to gasification and syngas cleanup, then we get through Fischer-Tropsch conversion and wax hydrocracking, we get diesel fuel and jet fuel. However, when we use natural gas and subject it to steam methane reformation in syngas cleanup, we get methanol synthesis, and methanol is then converted to gasoline conversion, and then finally you get gasoline. Methanol is in different forms, that is DMFC, that is direct methanol fuel cell, dimethyl ether, and finally biodiesel. For dimethyl ether, it is environmentally compatible propellant for spray. If we consider its physical properties, it is similar to LPG, however, exhibiting a high cetane number, that is CN. It exhibits a greater potential to substitute diesel being used in automobile engines and also LPG. Further on, with minor changes in the existing LPG supply chain, can be used for dimethyl ether as well. However, production economy is needed to be improved. This here you can see the chemical reaction for the formation of dimethyl ether, and certain properties are compared for dimethyl ether as well as diesel, that are density, lower heating value, cetane number, fuel equivalence, and GHG. These are the physical properties which are compared for different automobile fuels, that are gasoline, propane, CNG, methanol, and ethanol. We find that the highest octane number is there for CNG. The heating value in BTU per gallon is exhibited on the higher side for gasoline. And volume equivalent, for every 1 gallon of gasoline you will need 1.15 gallon of propane, 122 cubic feet of CNG, 1.8 gallon of methanol, and 1.5 gallon of ethanol. Then the type in which the fuel is stored, all the fuels are stored in the form of liquid with the exception of CNG, which is stored in the form of gas, in miles per gallon as compared to gasoline. The least is over here methanol. The tank size also is the least for gasoline, whereas all the other fuels they require a larger tank size. As far as the pressure is concerned, requires a high range of pressure. Then cold weather running condition is good for CNG, propane and gasoline. However, for methanol and ethanol, the cold running conditions are very poor. Also, when apart from gasoline, other fuels are used, we find that there is a power loss in the range of 5 to 20%. The maximum power loss or compromise on power is there when we use CNG. As far as toxicity is concerned, only propane and CNG are non-toxic. Gasoline, methanol, and ethanol are toxic, whereas methanol is considered to be very highly toxic fuel. As far as corrosiveness is concerned, gasoline is little corrosive. Propane and CNG are not corrosive in nature, whereas ethanol and methanol are found to be corrosive in nature. As far as the source is concerned, gasoline, as we all know, is obtained from crude oil, and as already discussed, propane, CNG, methanol, and ethanol they are obtained from unconventional sources, that is, natural gas, coal, sugar and starch crops, or biomass. Then we have fuel cells. In this fuel cell, the chief element that is used is hydrogen. As in the case of LPG, hydrogen cylinders are mounted below the floor body of the vehicle. This hydrogen is supplied to a battery which generates electricity, and on this electricity, the vehicle is run using a motor. Inside each fuel cell, hydrogen from the tanks is passed through a negative electrode. In this negative electrode, a catalyst is present. Because of this catalyst, electrons are separated from the hydrogen atoms. These electrons will now flow from the negative to the positive electrode in the fuel cell, as a result of which electricity will be generated. Also, hydrogen ions will migrate towards the positive electrode through an electrolytic membrane, where they will combine with oxygen that is obtained from air to form water. This is an example of a fuel cell. As we can see over here, hydrogen is given in the form of fuel. At the negative electrode, electrons are drawn out of it, and hydrogen ions they pass through an electrolytic solution. Electrons, when flow from positive to negative to positive electrode, they generate electricity, and when hydrogen ions they pass through the electrolytic solution to the positive electrode, where they combine with oxygen obtained from air and convert it into water. So this was something about the different types of alternative fuels that were used. Thank you very much.